Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 6 in the HTTP host header attacks module titled Host Validation Bypass via Connection State Attack. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portsfigure.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy. Select all content, all labs, and then do a search on host-based header attacks and go to lab number 6 titled Host Validation Bypass via Connection State Attack. Alright, let's get started. This lab is vulnerable to routing-based SSRF via the host header. Although the front-end server may initially appear to perform robust validation of the host header, it makes assumptions about all requests on a connection based on the first request it receives. To solve the lab, exploit this behavior to access an internal admin panel located at 192.168.0.1/admin, then delete the user Carlos. So the vulnerable parameter over here is the host header, and the goal is to exploit the host header injection in order to perform an SSRF attack and access the internal admin panel that is on an internal server and delete the user Carlos. Now, we do have a hint over here that says solving this lab requires features first released in Burp Suite 2022.8.1 version. We're using the 2025 version, so we should be okay. But if you haven't updated in a very long time, then you should update right now, or else you won't be able to complete this exercise. Alright, so in the previous two labs, we've performed a routing-based SSRF attack via the host header. So if you haven't watched them, I recommend that you pause this video, go watch the previous two labs, and then come back and attempt this lab. Now, this lab over here does have robust validation on the host header. However, it makes the assumption that all the requests that are coming through the same connection are based on the first request that comes in that connection. And so it likely does the host header validation on the first request and doesn't do it on the subsequent requests. Now, this is quite an interesting attack vector. It occurs when you have intermediary systems such as a load balancer or a reverse proxy that use the host header to route the requests to the correct backend server. Now, if this intermediary system assumes that all requests on the connection are intended for the same host, so let's say request 1, request 2, request 3, request 4, request 5, and request 6, if it assumes that all the requests on the connection are intended for the same host as the initial request, and it only validates the host header for that first request, then we can exploit this functionality by changing the host header to an arbitrary value in the subsequent requests that are sent over the same connection. So we won't be able to perform our exploit on the first request, but we will be able to perform the exploit on the second, third, fourth, and fifth, and so on requests. So any of the subsequent requests. And that's exactly what we're going to do in this lab. So let's access the lab. Now notice over here, I am using the built-in browser in Burp, and so all my requests are already being passed in my Burp proxy. Again, we're using the 2025 edition, which has the features that allow us to exploit this vulnerability. I am using the professional version, but you could perform the exact same steps in the community edition and you'd be able to complete the lab. So the first thing I'm going to do is click on Home and then send that request to Repeater. In Repeater over here, I'm going to click Send. It gives us a 200 OK, and it shows us this page right over here. So if you render over here, you could see that it shows us this page. Now, what I'm going to do is exactly what I explained earlier. I'm going to have two requests. The first one has the correct host header so that the validation could pass, and then the second one will have the host header equal to the internal server so that we could access the internal server and perform an SSRF attack. So to do that, I need two requests. So I'm going to send this one to Repeater again. And in the second request, I'm going to remove the host header and go back to my lab and grab the IP address of the internal server. Now, in previous labs, we had to perform an IP scan to identify which IP address has an admin panel and has a web server on it. However, in this lab, they've given it to us just so that it makes it a little bit easier since we already know how to perform that attack. So we're going to change the directory to /admin because we want the admin page. Now, if I send this right away, it redirects me to my application right over here. So if you change the host header to anything that is an incorrect value, it will redirect you to the public interface, which is this application right over here. But what we want is we want the admin panel on this internal server over here. So we're going to exploit this functionality by going to the first request, right-click, add tabs to group, and then create tab group. And we'll just name it attack. It can be named anything. Click on create. And now I should have 1 in my group, and I need to add 2 as well in my group. So we could have added it in the previous panel, but let's say add to group and to the attack group. Now I have 2 requests in my group. The first one is the valid one with the correct host header, and then the second one with my exploit. Now to perform this attack, the requests need to be under the same connection. So instead of clicking on send, I'm going to click over here and say send group in sequence, single connection. So under one connection, and hit send. And now the first request is performed as usual. In the second request, we're no longer being redirected. Now we're actually seeing a page, and if we render, we have access to the admin functionality. The reason this worked is, again, because the application is validating the host header on the first request, and it assumes all the other requests that are sent under the same connection have the same host header. However, as we saw over here, we've changed the host header and we were able to perform an SSRF attack and gain access to an internal resource. So let's go back to raw, right-click, and then I'm looking for show response in browser, copy, and look at that in the browser, hit send. And here we go, it gives us the functionality to delete the Carlos user. I'm going to click delete user. It shouldn't work from over here because we're trying to access functionality that doesn't exist on this domain. It only exists on this domain over here, which is an internal server. But the reason I performed that is because I want the structure of the request. So I'm going to send this to repeater. I'm going to add this tab to my group. So to the attack group. I'm going to remove tab number 2, but before I remove it, I'm going to take the host header where this admin functionality exists and put it in here. And if we go down, you could see it takes in the CSRF token and the username Carlos. And now, again, I'm going to send it as a group, 1 and 3, under a single connection. So it'll perform 1 first where the validation is performed, and then it'll perform 3 where it does not validate the host header. So send group, and we get a 302. It redirects us to the main page, indicating that the attack was successful and the user was deleted. So if we go back to the application, you could see it tells us, congratulations, you solved the lab. So we were able to successfully exploit this vulnerability and delete the Carlos user. In the next lab, we'll look at another attack vector that you can perform when you have a host-based header injection vulnerability.